Hello students, welcome back to maths class. This is a revision class for your quarterly, right? So there are 10 questions in this revision class. So you have to practice all these 10 questions thoroughly, right? Then you will have exam on these 10 questions. Okay, so first exam this year you are writing, so write this exam nicely, try to get out of marks, right? There is one saying, well begun is a half done, right? You will get confidence also if you get out of marks in this exam. Actually after this long gap, right, if you write one exam and you will get good marks, means it will boost your confidence also, isn't it? So now come to these 10 questions, right? So how I will explain just method wise. I cannot solve all the 10 at a time, just it is a revision. So method wise, concept wise, I will explain to you. Okay, I think already you are in a second year, no? You are perfect with these circles, with these long questions. Only long questions we are having. Okay, so come on, come to the first question. Find the equation of the circle passing through 3 points are given to you, right? So first important long question. So what is the first question? Come on, what is the first question? First we have to take a general circle equation. What is that? X square plus y square plus 2gx plus 2fy plus c is equal to 0. We have to consider this is the circle equation. Be the circle equation. This circle equation passes through that point. What is the question? Find the equation of the circle passing through first point. You will get first equation, equation 1, you will get it. Passing through the second point, you will get second equation, and passing through third point, you will get your third equation. We will consider those equations already. First equation 1 we have taken, no? So you take this one as 2, this one as 3, this one as 4. But actually we are having 3 equations now. In terms of GFC, see, if you substitute this first point in this equation, circle equation, we will get one equation in terms of GFC. Similarly, if we substitute the second point in this, we will get one equation in terms of GFC. Third point also, why this circle passes through third point also, so we have to substitute the third point also in this circle equation. We will get third equation in terms of GFC. Okay, so we'll get 3 equations in terms of GFC. Take 2 at a time and solve them and try to get your GFC. Definitely you will get it, right? So once you got your GFC, substitute in this equation. That will be your required circle equation. Once again, first we have to take the general circle equation, will be the required circle equation. This circle passes through first point, substitute wherever x is there, x coordinate, wherever y is there, y coordinate, you substitute in it, right? Then you will get one equation in terms of GFC, right? Next, again you take the second point, right? Substitute it, you will get another equation in terms of GFC. Third equation, another equation in terms of GFC. Solve those equations and try to get your GFC, right? Once we got GFC, substitute in this equation, you will get your required circle equation. Okay, so that will be the concept and method of your first problem, right? When 3 points are given to us, how we will find the circle means take the general circle equation and substitute the points. We will get 3 equations, solve them and try to get GFC values. Once we got GFC, substitute in the starting, right, in the general equation. That will be your required circle equation. Okay, so now come to the second question. What is your second question? If you observe, your second and third questions are similar, right? Method will be same, values are different, but method will be same, right? So method means some rules. First we have to take like this, we have to take like this. If you remember like this, no need to by heart entire problem. Okay, so come on, what is this? Show that these 4 points are concyclic and find the equation of the circle. What is meant by concyclic? Concyclic means the points which lies on a same cycle are called concyclic points. Here your cycle is a circle, right? So we have to show that all these 4 points lies on a same circle. Our topic is circle, right? So it is also one type of a cycle. Concyclic means if the points lies on a same cycle, they are said to be concyclic. Here these points, if lies on a same circle, they are said to be concyclic. So here we have to prove that all these 4 points lies on a same circle. How we will prove? Same like our previous problem. First you take only 3 points here, right? You take only 3 points and solve the circle equation by our previous method. What is that method? Take the general equation. In that it passes through first point, first equation, passes through second point, second equation, passes through third point, third equation. So all these equations will be in terms of GFC. Solve them, right? You take two equations, solve them and try to get your GFC. Then substitute in the circle equation. You will get your required circle equation in which these 3 points lies, but we have to show that 4 points lies on the same circle. Now in that circle equation you substitute the 4th point, right? If that point satisfies that circle equation, then we can say that these points are concyclic. Okay, concyclic means the points which lies on same circle. If all the 4 points lies on a same circle, then we can say that those 4 points are concyclic points. Okay, so first you take 3 points and find out the circle which passes through these 3 points. In that circle equation you substitute the 4th point. If it satisfies that equation means if you substitute the points in it, you have to get is equal to 0, right? Then we can say that that 4th point also lies on the same circle in which already 3 points lies, therefore they are concyclic. That is the concept. Same, if you solve first problem, second and third also same concept. Only thing is concyclic we have to prove. What is meant by concyclic? If all the points lies on a same circle, then they are said to be concyclic. Okay, so your second and third, right? These 2 questions are of same method, but the points are different, so you will get a different equations. You have to solve, you will get a different circle equation also, right? In that you have to substitute your 4th point. That point has to satisfy that circle equation, then only we can say that 4th point lies on that circle, therefore they are concyclic. Okay, next come to the third one. Actually third one also concyclic, but if you observe it, third one, yes, second and third are same. Now come to the fourth one. Fourth one is also concyclic, but if you observe your 4th point, one value is given as C. Generally points means they will be in terms of numbers 2, 3, 5, 7, -2, -6, 0, 2, like that it will be there. But here it is given that C8 and find that C is asked. So if these 4 points are concyclic, then find that point, that x coordinate of the point, isn't it? Y coordinate is 8. Find the x coordinate of that point if all these 4 are concyclic. So what is the procedure? First, same, by applying the first, second, third problems method, you find out the circle equation. How we will get the circle equation? You take the general circle equation. In that you substitute the first point, you will get first equation in terms of GFC. Substitute the second point, you will get the equation in terms of GFC. Substitute the third point, you will get your equation in terms of GFC. Solve by taking two points, you solve it, right? Try to get your GFC values. Okay, once we got GFC values, substitute in general circle equation, you will get your required circle equation. Once we got a required circle equation, since all these four are concyclic, this fourth point satisfies the circle equation. So you substitute this fourth point whose x coordinate is C. Wherever in your circle equation x is there, in its place you have to substitute C, and wherever y is there you have to substitute 8. Then you will get one equation in terms of C, right? You will get one equation in terms of C, quadratic equation in terms of C. Solve it, you will get your C value. Okay, so actually these three are concyclic problems, but here we have to show that these two are concyclic, but here already it is concyclic. Find the x coordinate. Already it is concyclic means this fourth point satisfies the circle equation. Just substitute, you will get one equation, and you take is equal to 0, right side, and you will get one quadratic equation. Solve it, you will get your C value. Okay, so that is your fourth question. Now come to your fifth question. What is this? Find the equation of the circle passing through 2 points, right? Passing through 2 points, and the center lies on this equation. Okay, so very simple. First, passing through 2 points means same. We will take one general circle equation. What is that general circle equation? X square. Throughout the chapter we have to use this formula only. X square plus y square plus 2gx plus 2fy plus c is equal to 0 is the general circle equation, right? This circle passes through this point. You will get one equation in terms of GFC. This circle passes through this one. You will get another equation in terms of GFC. And one more thing is given to us. Center lies on this line. What is the center of general circle equation? It is minus G minus F, right? Center is minus G minus F. This center lies on this equation 4x plus 3y minus 24 is equal to 0. Lies means it satisfies that line equation. In x place we have to take minus g, in y place we have to take minus f. Then you will get your third equation in terms of GFC. Now again you got 3 equations in terms of GFC. Take 2 at a time, solve them, you will get your GFC. Substitute in this equation. Finally, that will be your required circle equation. Okay, so next come to the sixth question. What is the sixth question? Find the equation of the circle whose center lies on x-axis, right, and passes through 2 points. Okay, so same thing. First thing is, if circle we have to find, then we will take the equation as a general circle equation. Let x square plus y square plus 2gx plus 2fy plus c is equal to 0 is the general circle equation. So it is given that, right, whose center lies on x-axis. What is its center? Its center is minus g minus f. This center lies on x-axis. So if you take any point on the x-axis, its y coordinate is always equals to 0, isn't it? If we take any point on x-axis, this is your x-axis, this is your y-axis. If you take any point, right, so what is this point? 1, 0. What is this point? 2, 0. Y coordinates will be 0. So here what happens? Implies minus f is equal to 0, implies f is equal to 0. So whenever center of this circle is minus g minus f lies on x-axis, any point lies on x-axis means its y coordinate is equals to 0. What is its y coordinate? Minus f is equal to 0. So f is equal to 0. Okay, so we got one value, f value. Now we have to get g and c. How we will get it? For that, here it is given that your circle passes through minus 2, 3 and 4, 5. So this circle passes through first point, you will get one equation. Your circle passes through this point, you will get another equation. So solve those two equations, you will get your g and c. Right. Once we got a g, f, c, substitute, you will get your required circle equation. Okay. So now come to the next question. Show that the two circles, these two circles touch each other. Find the point of contact and common tangent. See this question also. Show that the circles touch each other. Find the point of contact and common tangent. Method is same. Circles are different, so values will be different. So when we can say two circles touch each other, actually in these two cases our circles are touch externally, right? So our circles touch externally, right? So this is your point of contact. Okay, so this point of contact divides C1, C2 internally. While explanation time also, first time in your record, right? So if you observe, I said if the circles touch externally, point of contact divides C1, C2 internally with the ratio R1 is to R2, isn't it? So this is the radius of the first circle, this is the radius of second circle. C1 is center of first circle and C2 is the center of second circle, isn't it? So when we can say that two circles touch each other means if your distance between the centers C1, C2 is equal to R1 plus R2, right? The distance between C1 and C2 is equals to R1 plus R2, okay? Then we can say that the circles touch externally, right? So if C1, C2, the distance between us, the first center and the second center, that means first of all you have to find the center and the radius of first circle and center and radius of second circle. After that you have to check this condition. Why? It is given that show that the circles touch each other. So when they touch each other, first touch externally we will check it. So in both cases these two circles touch externally and these are the repeated questions, selected questions. That's why I am explaining. Okay. So find out the distance between C1 and C2. How we will find distance between 2 points? By root of x2 minus x1 whole square plus y2 minus y1 whole square form, right? So find out and add the radius. If both are equal, then we can say that the circles touch each other externally. Then the point P divides C1, C2 internally. When the circles touch externally, point of contact, right? P divides C1, C2 internally in the ratio R1 is to R2. So we have to find P point by using which formula? Internal section. How we will find? It is mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. We have to use where your m and n are R1 is to R2 and x1 y1 is first center and x2 y2 is second center. With that you will get your point of contact and equation. This is point of contact. Next we have to find equation of common tangent, isn't it? So for that what is the formula? S1 minus S2 is equal to 0. So just you deduct first circle minus second circle, you will get your equation of common tangent. Where it lies? here. This is your equation of the common tangent. Okay, so these two problems, same concept you have to apply. First you have to find center and radius, right, of first circle, center and radius of second circle. Then check the condition, the distance between C1, C2, that must be equals to R1 plus R2. Okay, so then you find out, you write down both are equal, C1, C2 is equal to R1 plus R2. Therefore, the circles touch externally and point of contact divides C1, C2 internally. Find out the point by using this formula. Then you write down the equation of the common tangent. Okay, so next come to the ninth question, right? What is your ninth question? Find the equation of pair of transverse common tangents. So how we will say, when the two circles do not touch each other, right? Two circles do not touch each other, we will get two pairs of common tangents, one pair of direct common tangent, one pair of transverse common tangents. So transverse common tangents means these are the tangents, right? These are called the transverse common tangents. Okay, so here we have to find first P, right? Then you find out transverse common tangents at the point P, right? This is one tangent and this is another tangent at the point P, are called the transverse common tangents at P, right? So what is the formula? Means its formula is S square is equal to S11. So for this S11 means we have to substitute x1 and y1 in S equation. How we will get x1, y1? It is nothing but point P is x1, y1. How we will get this point P means, see, observe, your P divides C1, C2 internally, right? So you first find out the P point. What is your P point? P is the point which divides C1, C2 internally with the ratio R1 is to R2. Okay, where your internal bisection formula, you know it very well. Previous class we discussed mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, where m and n are R1 and R2 radius, and your x1, y1 is first center, x2, y2 is second center. So when we will get transverse common tangents, if condition is C1, C2 is greater than R1 plus R2, the distance between the two centers is greater than R1 plus R2, the distance between the two centers is greater than R1 plus R2, right? Then we can say that there will be two pairs of common tangents. One pair is direct common tangent, one pair is transverse common tangents. These are called the transverse common tangents. Here question is pair of transverse common tangents. So we have to find the tangents at the point P. For that sake, first you find out your point P. How you will find your point P? P divides C1, C2 internally with the ratio R1 is to R2. Apply internal bisection formula. You will get your P. Once you get your P, then equation of the transverse common tangents formula is S square is equal to S into S11. You can take S as any circle equation. Two circle equations are given to us, but generally we will prefer first circle. I solved by taking first circle. Once you go through this video, you will know it little bit lengthy, but most repeated, most important. Now only you are having lot of time. Now only you practice perfectly and get it right. So that 7 marks will be in your pocket. Okay, so come on, next come to the 10th question. What is the 10th question? So what is the 10th question? Show that 4 common tangents can be drawn from these 2 circles. Find the internal center and external center. Right. 4 common tangents can be drawn means now only we discussed what is the condition. I said C1, C2, the distance between the centers is greater than R1 plus R2. Then there is a possibility of 2 pair of common tangents. Pair means 2. I am saying 2 pair means 4, right? 2 plus 2, 4. So there will be 4 common tangents when the 2 circles are away from each other. So first thing is we have to prove this one. That means by taking the first circle, you find out the center and radius C1, R1. Take the second circle, find out the center and radius, that is C2 and R2. After that, you find out the distance between the centers, that is C1, C2, right? That must be greater than R1 plus R2. Then there is a possibility of 2 pairs of common tangents, right? One pair is called direct common tangents, right? They will intersect like this, right? Another pair will be transverse common tangents, right? One pair is direct common tangent, another pair is transverse common tangent. The point of intersection of transverse common tangent divides C1, C2, right? In R1 is to R2 ratio internally, and the point of intersection of direct common tangents, right, Q divides C1, C2 externally. Your Q point is external of your C1, C2. So Q divides C1, C2 externally and P divides C1, C2 internally. This is called internal center. That Q is called external center. So you know internal bisection and external bisection, isn't it? Formula. So for P, to get P, we have to take which formula? It is mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. Right? This is internal cutting, right? P is the internal center. P divides C1, C2 in the ratio R1 is to R2. So here M and N are R1, R2, and X1, Y1 is first center and X2, Y2 is second center. Okay. Next, we will take Q, external center. What is the difference? Just here, this is mx2 minus nx1 by m minus n. Instead of plus, we will get minus. Similarly, it is my2 minus ny1 by m minus n. Okay, so just in place of plus, you take a minus, that will be your external center. Okay, so be clear with the concepts. So here condition, when the 2 circles touch externally, if C1, C2 is equal to R1 plus R2. If circles touch externally, point of contact divides C1, C2 internally. Okay, so and if C1, C2 is greater than R1 plus R2, then 2 pairs of common tangents are possible. One pair is called the direct common tangents, another pair is called the transverse common tangents. Okay, so while finding the equation of transverse common tangent, we have to apply one formula, that is S square is equal to S11. For that we want the point, right, from where we are drawing those 2 common tangents. So that point divides C1, C2 internally. So by applying that formula, first of all we have to find P, then we have to take that formula to get our transverse common tangents. We will get 2 common tangents for the circles. Okay, so that is those are the methods. Okay, so you can remember the problem like this. Don't by heart each and every step. Just so in this problem, this is the condition. If this is the condition, then two circles touch each other. If this is the condition, two circles will be away from each other. If they are away from each other, two pairs of common tangents are there. In that, one set is direct common tangent, one set is transverse common tangent. Like that we have to find. And here the point of intersection of transverse common tangent is called internal center. The point of intersection of direct common tangents is called external center. So internal center, internal bisection formula, external center, external bisection formula. Okay, so these are the most repeated, most expected long questions from the circles. So make it perfect, right girls? Practice these problems perfectly. Okay, so that I think almost all the girls will get out of marks. Okay, so that will be encouragement for your next studies. Next means next 3-4 months studies. Okay, so prove yourself girls. Okay, all the best. That's all for today.